All right. Now, talking about geometric sequences, we've been through arithmetic sequences and arithmetic series. So, the next week when we are looking at geometric sequences, we're going to be able to define what a geometric sequence is. You need to think about it in terms of recursive rule as well as a general rule. Now, you should be able to define geometric sequence recursively and in terms of a common ratio. In these terms of a geometric sequence, given a rule, should be able to write the recursive rule for geometric sequence given the terms. You should be able to derive the general or the explicit rule for a geometric sequence and make the connection to exponential relationship. Remember, I did exponential relationship a couple of weeks ago. Now, it's coming back to haunt you. Hopefully not. Hopefully you remember. Find the nth term of a geometric sequence. Give two terms of geometric sequence. Find the common ratio, first term and hence the rules, and verify whether a given value is part of a geometric sequence. Now, let's start off by looking at these two sequences here, 1 and 2. If you look at that, somebody tell me the difference between the sequence 1 and sequence 2, please.
One's going up by 3,
Very good. So I hear 1 is plus 3. The other one is times 2. All right. I also hear that somebody told me that this is a arithmetic sequence with a common difference. And sequence number 2 is actually a geometric sequence with a common ratio of 2. All right? Now, you need to know the recursive definition of a geometric sequence. A sequence is said to be geometric when there exists a common ratio between the terms. So you must think about it as a common ratio instead of a common difference now. All right? What I'm going to do is show you the recursive rule of a geometric sequence. The recursive rule of a geometric sequence, Tn plus 1, is equal to R times Tn, and T1 equals to A. What you need to know is you must be able, for a recurrence or recursive rule, you must always take your first term, which is A in this case, and then Tn plus 1 is the ratio or the common difference times the previous term. Alright? R is the common ratio and A is the first term. We use D as the common difference. Here we use R as the common ratio and A is the first term. Now, if you consider this Tn plus 1 equals to 3Tn, Tn equals to 2, think about how you would describe it. Alright. If you do it if you look at that, maybe Megan, how would you describe that? Yep. All right. Times it by 3. Now, what other information do I have to give it? Starting with 2. Very good. So, you've already got the information you know. Using your own words. You start with the number 2. The next term is multiplied by 3, and the process goes on. So, you need to specify first term as well as the process. Therefore, you should be able to find what T2 is, correct? Which is? And can you write out the first 5 terms of this sequence? You've got 2, you got 6. You should be able to multiply. It will be a calc-free question if something like this came out. It will be part of a question, which would be that. All right? 2, 6, 18, 54, and 162. Now, let's go on with the next bit. Exercise 1 to 4 from the thing that I gave you, and we will discuss each. We'll discuss each question at a time. So do 1 to 4, please. One to 4 basic questions that you should know.
1B.
I would say that I'm going to discuss a little bit more with 1B, 1D, and a few of them. I'll discuss a few of them. I'll show you my answer. Maybe D, I might let you use your calculator.
No, it's
1D. But
so it's 5. 5 by -3.
what using the calculator instead? Were you here yesterday?
Yeah. Yeah.
Were you here yesterday?
And then what's 45 minus 50?
All right. Now, everyone, let's have a look at the answer to exercise 1A, B, C, and D. What can you notice about question 1B and 1D?
It's alternating. Negative.
Okay. What causes it to alternate?
Negatives times negative.
So negative times negative. Why? Where? What particular term?
The even terms.
So, okay, sorry, not terms. What? Which is it? Is it T1 that we're looking at, or is it the ratio we're looking at? The ratio. So, if the ratio is negative, what happened? It will go alternating sign, up and down, up and down. All right. It doesn't matter whether T1 is positive or negative. It will just alternate: positive, negative, positive, negative, positive, negative. All right. That's one thing that I want you to notice. If you've got a negative ratio. Now, exercise 2. It's pretty straightforward. You should be able to write out the recursive rule. For that, stating T1, definitely always state T1. Now, exercise 3. What you need to do is to be able to work out the ratio. And I've given you in there, in your handout, the common ratio between terms can be found by dividing any two consecutive terms. Tn plus 1 divided by Tn will give you the ratio. So you should be able to work out the ratio of A, B, and C.
Sir,
Yeah?
is 5 supposed to be in the thing? It says recursive sequence.
Sorry?
Question 5. Exercise 5 says.
Question 5 on there. Don't go on the. Oh, it's a geometric sequence, my typing.
Okay.
Sorry. Don't look at question 5 yet. Let's do question 3 first. Don't jump. I still need to discuss a few things before we go on to question 5.
Yeah.
So it's my typing. It's not arithmetic sequence. We're looking at a geometric sequence. All right. Now, exercise 4. You should be able. It doesn't matter whether you have your sequences in numbers or your sequences in algebraic expression. You should be able to work out the R. So the R is basically 3x squared divided by square root of 3 times x. And therefore, R is square root of 3x. So therefore Tn plus 1 equals the square root of 3x times Tn, where T1 is square root of 3 times x. Alright, let's move on. The next one I want to look at is the general rule or the explicit rule of the nth term. Now if you look at the recursive rule that I gave you, Tn plus 1 equals to 2Tn, T1 equals to 4. Can you therefore write down all the missing numbers in this table, please? You should be able to work it out. You know that from n1 to n2, this is multiplied by 2, and this should be multiplied by 2, correct? And it should be this, so on and so forth. Alright, let's have a look at the statement here. When we jump to the third term, how many times have we multiplied the first term by?
2 times.
2 times. What about the fifth term? 4 times. 9. And therefore, nth term is n minus 1. Alright? So, you know your starting term is 4. And you know the ratio is 2. How would you write it in the explicit form? Without worrying about specifying T1. How do you implement T1 in that T1 is the general rule.
T1 is
Alright, so T1 is A, so therefore, in this case, what we could write is Tn equals to 4 times 2 to the power of n minus 1. Alright, can you recognize this as a form of an exponential? When we did exponential,
Yeah.
this is what we do.
2 to the power of 8.
Correct? So, to generalize it, the general rule or the explicit rule of the nth term for a geometric sequence, Tn is therefore equals to A times R to the power of n minus 1. Tn equals to A times R to the power of n minus 1, where R is the common ratio, where you can determine using Tn plus 1 divided by Tn, and A is the first term. So therefore, using the general form Tn equals to 4 times 2 to the power of n minus 1, can you determine the 10th term in the sequence?
Yes.
What is it?
4 times 2 to the power of 9.
So what is 4 times 2 to the power of 9?
Good question.
Come on, the games that you used to play on the on your phone?
48.
2048.
Oh,
I'm sure you have played that game before, 2048.
Well, you can score power 2.
Yes. All right. So, now, can you do exercise 5, please? I would like to discuss exercise 5. It's actually not arithmetic sequence, it's geometric sequence. It's my fault. Yeah, I would say C. I would give it to you as calculator, but the rest, maybe not. Maybe not.
determine the general rule of the.
Yeah.
What it counts
Sorry. It's to the power of 11
Oh,
because it's 4 is to the power of 2.
yeah.
All right. So I let me see. Would this be? Yeah, it might be. Yeah, some 10th term will be quite a big number. So yeah, I think calculating the 10th term in the sequence will be a calculator assumed. Pretty sure I use calculator for that. So definitely when I type in the handout, I wrote arithmetic sequence, but I did it correctly for the PowerPoint.
To make really small bubbles with this.
You could say it.
Bubbles? Yeah, with that one there.
One thing to really avoid is using a calculator on your computer, because if you're used to using that, in the exam,
Yeah.
you will be in a bit of a you won't have your calculator. So don't avoid if you haven't got a calculator, just borrow one from me. I mean, you should be able to write the general term for the sequence like straight away. Looking at the A, you know the A and you know the R. All right?
Wait, can you put the negative bracket back?
Couple more minutes, I'm going to reveal my answer.
You have to put the negative bracket, right?
Sir,
Yeah?
Inside the bracket.
Yep. Yes?
if you have two different terms, and then you find the ratio of that, is that an element?
That's R, yeah, that's correct.
You know how,
What if it's like T1 and T5? Same thing. 'cause you see
I'll show you in a few minutes. When we talk about T1 and T5, I'll show you in a few minutes. All right? I will show you in a few minutes when we are talking about T1 and T5.
or if A is negative, so it's negative.
You're going to think about how to use your exponential function to do that.
Oh god.
All right, let me reveal the answer. All right, so you do have big numbers and something like
Oh my god.
here, 0.00028. Happy for you to write it in scientific format. In fact, you should because you know how to write this in scientific format. Here, I will accept 4 decimal places, that's fine. And this one, huge number. So you should be able to use your calculator for finding the 10th term. I'm going to assume that all of you agree with my answer. Thank you. Let's look at what Kaylan just asked me. All right? Finding the rules from 2 terms. So what in your prior mathematical knowledge do geometric sequences related to? I just told you. Thank you, exponential function. Now, let's concentrate on this for a few minutes. Right? Without looking at your question paper or anything else, I want you to concentrate on this. All right. I am going to, this time, a little bit confusing because I actually define one of this number as A, one of this number as B. But the A here is not the first term. All right? Just remember. I just define it that way. All right. Now, let's these 2 terms be Tm equals to B. So let's say T9 equals to B and T4 equals to A. All right? Remember, this A is not the first term. This A is related to this. All right? When I realized the mistake of that, I was too lazy to change my slide already. And I'm sure all of you will understand that this is not A. This is not the first term A. All right? So now for the general rule. You know that Tm equals to A times r to the power of n minus 1. Tn equals A times r to the power of n minus 1, correct? Yeah? So, if I use Tm divided by Tn, I can actually reduce this term to r to the power of n divided by r to the power of n. Correct? Now, if you do not believe me, this is what you do. A times r to the power of n times r to the power of minus 1 over A times r to the power of n times r to the power of minus 1.
Yes.
And therefore, you can cancel off the A, r to the power of minus 1, r to the power of n over r to the power of n. Am I right?
Yeah.
Thank you. So therefore, what we can do is, once we know that, we can write r to the power of n minus n as Tm minus Tn or B minus A.
But doesn't n
Alright.
have to be n plus 1?
Here, it is n plus 1. See, I have reduced that because r to the power of n minus 1, r minus 1, n minus 1, r to the power of n minus 1. See that?
So it doesn't have to. So the actual rule r equals like tn plus 1 over tn.
It's just because the way I rearrange it, I could eliminate minus 1.
Like any two terms as long as
Yes.
you say n minus 1.
That's right. That's right. That's right. So r to the power of n minus n equals to b over a. All right? Do you all agree with me? So based on this, let's just remember this a is on the first term. We can actually work out the ratio r. So we know r to the power of n minus n equals to b over a. So r to the power of 9 minus 4 is 514 over 16. And therefore, r to the power of 5 is 32. R is a fifth root of 32, which is 2. And then, using the common ratio, you could work out what a is. Tn equals to a times r to the power of n minus 1. Yeah? So therefore, a equals to 2. And then, you can state the rule in the required form, which is Tn equals to 2 times 2 to the power of n minus 1, or the recursive rule, Tn plus 1 equals to 2 times Tn. T1 equals to 2. All right, happy? So you should know that this is not given in your formula sheet. If you want, make sure that you have got in your notes. All right. Next one. Again, these are not in your notes, but you should be able to derive it. So you know that Tn equals to a times r to the power of n minus 1. Therefore, a, the first term, is Tn over r to the power of n minus 1. Correct? So it's just rearranging. That's all. Again, obtaining a value for r, knowing a, is again rearranging. Alright, you know r is therefore Tn divided by a to the power of 1 over n minus 1. Just basically rearranging. Again, if you don't want to rearrange, write this down for your formula sheet, for your notes. Now, calculating the value of n is really beyond the level of this course, so I'm not even going to worry about it. So you just need to be able to calculate a and calculate r. That's all.
Sir?
Yep.
Do we do like notes
Hmm? Sorry?
geometric? Do we do like notes for geometric?
So,
Anal.
yes, there will be situation when you look at a naught. I will show you some question Monday.
Then that means that will be different, right?
Hmm?
It's not n minus 1.
Yeah, if it is a naught, it will be r a naught times r to the power of n. That's all. All right, that's the minus
Is
1.
Friday a revision?
Sorry?
Is Friday a revision?
Tomorrow is for you to catch up with your homework.
I need that.
All right, next. Exercise 6 to 8, please. Exercise 6 to 8. We have done exercise 6 to 8. Once I've discussed it, you will have time to do some work.
Wait, the exercise,
They are all geometric sequences.
you can't, oh wait, you can third root and then you can't.
Calculator.
No.
Some of the third root you can use
No,
calculator.
for 8,
root.
you don't need.
You don't.
Yeah.
8 is just pretty straightforward. You don't need your calculator. All right. Cube root of 8 is
No, cube root of negative.
2.
Minus 2.
Yeah, minus. The host is
Oh, for a copy of this.
because the first time it 1,500,064. No, that's a bit try.
I mean, I'm pretty sure if you need to look up cube root of really big numbers, you have the calculator.
This one? So
What's yours?
Wait, what do you 19 root?
Oh, good.
That's like some of the.
Yeah, that's more normal. That's the
What is that?
that's only normal because
Is there an
That is pretty bad. Yeah.
I mean, with exercise 6, it would be like part of an exam question or text question.
I do have it
So you should be able to find the ratio.
Using the other one.
Some of you might use calculator, you might need your calculator. Some of you.
The answer is 7.
Yeah.
I'll review my answer in a few minutes.
20 minus 1.
I cannot remember what I do. I'll put it this way, I don't really want to remember what I do. So if you know T2 and T5, you should be able to work out what your ratio is, and then you should be able to work out what A is. So, therefore, you should be able to work out T20. Alright? Now, question like this. Use your information. What is available? R equals R to the power of n minus n, 5 minus 2 divided by equals to minus 80 divided by 10. So therefore, R to the power of 3 or R cubed is minus 8. R is therefore half, minus 2. And then work out A. Once you work out A, you should be able to write out the general rule and find T20. Alright, exercise 7.
How you not doing now?
Have you done this?
Yes.
How do you do question 8?
Yeah, I'll talk to you in a minute. Let's do exercise 7 first. Have you done 7?
Yeah.
So, answer, if you have done 7, this is how I did it. I know A equals to 3, I know T20 is whatever. So I can work out R is 2, and therefore Tn, we want the general rule, is 3 times 2 to the power of minus 1. Alright? Now, how do we do exercise 8? Alright. First, everyone, focus here for a minute, please. If this value is A, this value is, let's say B. This value is C. Alright? To find R, is actually R equals to B over A, is also equal to C over B. Alright? That's enough hint for you to try that question. That's enough hint for you to try that question. Oh, so how would you do it?
You can factorize. 3x plus 3. Oh, sir. Very good, very good.
Oh, no.
That's so
It's a light bulb moment.
It's so smart. Oh my god. Okay.
Like I said, I'm more experienced than all of you, alright? That's all I can say. I've done questions like this
But then you get to 5 in the third term for C. You get 5 outside of
So can I please use
2x
the
plus
calculator?
1.
Yeah, you can use a calculator, but I don't know whether it helps with this one.
5
I don't know whether it helps.
How does that? That's not what you need.
Does it help?
Wait, I don't. What?
It actually doesn't really help with the calculator. You don't need a calculator.
So you don't need calculators. You don't.
In fact, if you think too much, it will complicate things. Try not to complicate things.
So 10x plus 5 equals 9x plus 1.
Ah, somebody's got it. I hear the right word. Yeah.
Yeah.
Yeah, you got it. Yes, correct.
All you do is do 3x plus 3, factorize x
Yeah.
plus 1, take that, and then
So you get R plus 3.
Yeah, that's it.
Wait, what do you mean?
Exactly what I did. So 3x plus 3 divided by x plus 1 equals 10x plus 5 divided by 3x plus 3.
x equals minus
So
Oh.
I can factorize the numerator for the fraction on the left hand side. And so therefore x equals to 4. And now therefore what happened is x equals to 4, and you can check that it's a correct sequence. Alright?
Shouldn't that? Okay, wait, I have a question, right? You know how to find R, you do Tn plus 1 over Tn, right? So you end up with R equals 3 if you do 3x plus 3 over x plus 1. So then, but that isn't the common ratio for B to C.
It is common ratio.
But no, because you don't times 3x plus 3, you don't times that by 3 to get 3x plus 5. So you know how from
Okay, alright.
A to B-
Alright, yes. It is not, you know why? Because this time x is fixed. X is fixed.
Yeah.
You are looking for x. X cannot be any number, x can only be 4.
So is this a C? So could you get the rule for this? The general rule. There isn't there.
You have to, no, there's no general rule because x is fixed.
A equals 3. That's all you got.
This divided by that will not give you 3 because x is fixed. You have to find a number.
Okay, we can use this.
Alright.
But it is a sequence.
It's a sequence.
So there should be a rule.
But this is a fixed sequence with a fixed number x. It's not, the x is not variable. Alright?
So
X is not vary, it's fixed, yeah, it doesn't change, therefore.
the numbers still change.
Now, if you try other numbers, it will not
X
work.
has to change with the variable. So you have to have
Yep, yeah. Alright, now, let's have a look. 2 more slides. Everyone, focus please. 2 more slides, last 2. This is the time that you need to learn the word convergent and divergent. Alright? Now, let's have a look at the 2 graphs, the left 2 graphs. Can you describe the behavior of the graph? As n approaches infinity, what happened? What would happen to the Tn for this one? Yep, what about this? Tn approaches? Negative infinity. So therefore, what we do in this case is we call it divergent. Yep. It goes on and on, it diverges. What about that one? As n approaches infinity, what happened to Tn?
approaches 0.
For both of them? Yeah? So that approaches 0 and therefore it converges towards 0. This is called convergent.
Converse.
Yeah? Convergent. So that's one more slide for you, the last one, when the R is negative. You could have situation which converges or diverges. So one is convergent, the other one is divergent. So that's divergent, and that's convergence. It goes closer and closer and closer and closer to 0.
Wait, so what's it?
All right.
What's the difference?
Differences go up and keep going. It will not. You can't even describe the behavior because So you can go to positive infinity, negative infinity, keep going. So this one goes closer and closer to 0.
Converge goes closer to 0.
Yes, yes.
As like,
Converge to a number.
oh, to a, like,
yeah, that's right. Yep.
How do you do that?
Sorry?
What if n is on 1.5 and then it's very negative 2?
Alibaba has total 0.
Nah, don't worry about it. I haven't have a clue. If it is a complex number, I wouldn't have a clue. All right? Well, I'm not dealing with complex number here. Yeah?
Can you go back to the previous one?
Yeah, I can.
Yeah, okay. Oh, I got the wrong.
All right, back to the previous slide.
So they're both the same.
One goes positive infinity, one goes towards negative infinity. The other one approaches 0.
Is n x or y? N is x.
And it's x.
What is n? Just
The,
like a number of the
the
sequence.
number of the sequence, the term, the number of the
Right,
term.
that's a.
All right. So now I'm going to stop here. I will let you do some work. And that's it.